So in this video, let us learn about hydroelectric power plants. So hydro, which is nothing but water. The hydroelectric, which is nothing but the electricity is produced with the help of water. So hydro, which means hydel, it converts the hydraulic energy present in the water to electrical energy with the help of generator. So in hydro turbine power plant, the water which falls from the several height, its potential energy is converted into the kinetic energy. So and this kinetic energy is converted to the mechanical energy by allowing the water to flow through the hydraulic turbine runner. So in hydraulic turbine runner, the mechanical energy is converted into electrical energy which is coupled to the turbine shaft. So generally the hydel power plant, the power calculation is noted as WQH and note. W which denotes the specific weight of water, Q which denotes the rate of water flow in the pipe, H which denotes the height of polar head. So depending upon the height level, the output power is calculated, and the N is denotes the efficiency of conversion of potential energy into mechanical energy. So generally the hydro projects are developed for this purpose in order to control the floods in the river, and the hydro power plant is majorly used for the generation of power and storage of irrigation water. So under water abundance we may use the storage and the storage of the drinking water supply. So site selections. So site selections, the hydro power plant majorly located where near the water is available and it having the tendency capable to store the water, and the height of the water head level from distance from the load center, and that is easily accessible to the site. So generally the hydro power plants can be classified as storage plant and runoff river plants. So under storage plants it is classified into head levels. So one is high head plants, and second one is low head plants, and third one is medium head plants. And similarly the second classifications of hydro power plant is runoff river power plants. So runoff river plants is having with pondage or without pondage river plants, and the third type is pumped storage power plants. So depending upon the classifications, the first storage plant which denotes the height levels, so maybe the majority water levels under the height, whether the head plants is high or either low or medium. And similarly runoff river power plants which having with pondages and without pondages. So this one is a layout of hydroelectric power plants. So the major components is the main important source of hydroelectric power plant is dam. So behind the dam the reservoir, and moreover for hydroelectric the output can be calculated with the head level. So from this dam the water is passed to the turbine with the help of pipe, and it having penstock which is the largest tunnel of this hydroelectric power plant. So from this turbine the hydraulic energy from the water gets mechanical output. When it coupled to the shaft it produces the electric generator. And the major components of hydroelectric power plants are reservoir, the intake process, penstock, powerhouse, generator, turbine. So major component, first thing is dam. So dam is the most important component of hydroelectric power plant. So the dam is filled mainly on the large river which having abundant quantity of water throughout the year, and it should be sufficient, and the height of the river should be sufficient in order to build location is built near to this sufficient. So the second important is water reservoir. So behind the dam the water reservoir is stored. The water in the reservoir mostly located under higher than the dam structures. And the third one is intake or control gates. So the control gates are the built inside the dam. So water from the reservoir is released and controlled through these gates. So these gates are generally set as inlet gates, because the water when it enters at the power generations unit through this gate only. When the control gates are open, this water will flow through the penstock due to gravity and towards the turbine. So when the hydraulic pressure which hits the turbine starts rotating, and then the hydraulic output is fed to this turbine, which produces mechanical energy, and then it produces electrical energy, which is shaft coupled with the generator. And the next important component is penstock. So penstock is nothing but the longest pipe or the shaft which carry the water flowing from the reservoir towards the power generation units, which comprises turbines and generator. So the water in this penstock, which possesses the kinetic energy due to its motions and potential energy due to its height. So here the total amount of power generated in the hydroelectric power plant, which depends upon the height of the water reservoir and the amount of water flowing through the penstock. So the amount of water flowing through the penstock is controlled by the inlet gates, that is control gates. The next one component is water turbines. So the water turbine, the water is flowing from the penstock, which is allowed to the power generation unit is water turbine, which houses the turbine and the generator. So next one is generator. So generator is nothing but electricity is produced. The shaft of the water turbine rotates in the generator, which produces the alternating currents in the coil. It is then rotation to the shaft inside the generator, which produces magnetic field. Again it converts into electricity with the help of magnetic field inductions. So because of turbine shaft rotations, the crucial productions of electricity is achieved. So kinetic and potential energy of water is achieved. So this in hydroelectric power plants, potential energy of water is converted into electricity. Thank you.